Hi everybody, this is Shankar Somajla. I'm going to give a short demo on my session, which is market basket analysis revisited using SQL pattern matching. So, to begin with, let's see what market basket analysis is. So, it's a means of finding patterns within a set of records. So, finding patterns in data, essentially, it's a big data problem. But it's also it's a fairly easy and easy to understand and easy to execute machine learning use case, because the bulk of the analysis is done using conditional probability. So and it's also well defined, has well defined KPIs which are used for doing the analysis. So this is possible to be done across multiple industries. So let's begin. So let's say this is our input data set. Typical market basket analysis, MBA, is you take transactional data of master detail nature. So in this case, we have transaction ID as the parent key and the product ID as the child key, the line items. So in my case, the products are single letter products. This is just a small data set to finalize the functionality, and then we would expose the solution to a bigger data set. Okay. And so in this case, if we have a transactional data input data set of this nature, market basket analysis consists of finding patterns within the data. So which product sells with which other product, so long as the confines of the transaction being the transaction ID, the repeated master key. So using this input, you would find rules of this nature. Let's say Q and R implies B, and this is just additional metadata that we have in our solution. Essentially, market basket has B and R implies Q, comes with rule support of 0.307, which would be like 30% support. Rule confidence of 80.80, so 80% confidence. And the lift in this case is 1.455. So these are the three standard KPIs which govern market basket analysis. And usually we don't go into more KPIs, but there's a lot of literature which deals with these KPIs and certain use scenarios wherein these KPIs are not sufficient. So in general, the most default cases, we try to collect patterns or rules in which the lift is greater than, which have a meaningful support. So we ignore rules which are very low support. And we try to get the best confidence possible for competing rules. But so long as the lift is more than one, lift being more than one is one of the default criteria to select rules. So some of the other examples are examples of market basket are you can use products and get rules, but you can also artificially introduce tags or additional elements of the transaction as if they were artificial products, and then get behavioral rules or payment. You can add, let's say, payment mode as one of the criteria, as one of the input tags, and then try to analyze which products are bought with which mode of payment. What do customers buy when they pay through the wallet? What do they buy when they pay through cash at, let's say, 7-Eleven or something like that? So that's where you have a lot of additional means of doing market basket analysis. So let me show you a small example of that in our example. Sorry. So for example, I have 3 such modeling exercises already laid out for us. So if I select model ID 1, this is the first column is indicative of the model ID. So for the same data set, I have model 1, which is the default one, and I have transaction ID. The same one is just shown through the report now. The reporting tool in this case is Oracle Analytics Cloud. So I have transaction ID 1 with 5 products with their amounts and quantities and units sold in the total transaction amount, and so on. So I have, as I show you, I have essentially 13 transactions in the overall. Then I have a different modeling exercise kind of painstakingly created through the use of these artificial types. So one more thing I should explain is that the bottom is when I select a model here, the right side view refreshes to show the products which are involved in that model, and the bottom would show the transactions which are there in the particular model. So when I select a model ID 5, I see some difference. I should see. So for example, the transactions have been artificially enhanced to include this additional tag. So I have created, so in this case, this is a model number 5 is a analysis wherein I give preference or I include the time of day column as an additional tag within the transaction. But there are other key elements to the transaction. You would notice that this doesn't get any of the rules, so that the numbers don't really get fixed. Then the transaction amount doesn't change as a result, etc. So this is one way of doing it, getting time of day into the picture. And the products, if you see on top, I have now the different time of day products, early hours, evening, late night, etc., as well as the default, all the rest of the normal products. Okay, and then I'll show you a different example of the same, which is column model number 6, which is again just the default transaction data set, but this happens to be a partition data model, data set. So in this case, I'm creating what are called partition-based market basket analysis using the time of day as an example, as the partitioning column. So I would, I'll just switch over. I would end up getting rules of this type. So for example, for the model ID 1, I would get BP implies C as one of the example rules. But when I introduce, for model 5, when I introduce this as a virtual product, I would get a similar such rule, which would also include early hours within it. So this artificial product is included as part of the rule. But when I build a partition model, in that case, I get the partitioning information as a partition column metadata, and the same rule would be evaluated or would be displayed with different support row, confidence and lift. So this is because in this case, called model 1, this pattern BP implies C is evaluated across the entire data set, whereas in this case, it's evaluated within the confines of a partition, which is early hours sales alone. So it can happen that this is like the global profile of the rule, and this is a partition or a localized profile of the rule, with partition column being this one, time of day, and the value of the partition being early hours. So for example, this rule is more prominent within this partition at 60% support compared to its prominence in terms of support at a global scale level. Okay, so that's the modeling exercise which is done as part of ETL, etc. The value proposition of this solution comes about that I don't need to. So one second, let me go back to my presentation. I'll just jump to this. Essentially, what happens is it's a lengthy modeling exercise, and you would wish there is an easier way, and that's where SQL pattern matching comes in. Okay, so by virtue of using SQL pattern matching, I can take the model, which is model ID number 1, and then introduce the time of day as a runtime field to distribute the data set, to partition the data set on. And by doing so, I get both its global profile as well as its partition level profile. or the calculation of the KPIs at the partition level. So I can do this at runtime, and I can kind of prepare the dashboards and the KPIs and the formulas and so on, such that a business user who doesn't know machine learning, or who doesn't know market basket analysis in terms of its, who understands it as a end user, but who is unable to code and codify the KPIs, is able to benefit from a dashboarding, BI dashboarding tool set features. So by dragging and dropping time of day here, I get its earlier profile. And this is truly dynamic. It allows for self-service analysis. So we can drag and drop, let's say, if our data set was a million record data set across multiple countries, a country could be a natural choice for partitioning, and you could get rules. A given rule of interest could be evaluated across multiple countries, so that you get both its global and country level profile for that. So that's the main goal. And I think just one more point while I have this. So essentially, I go from the typical market basket analysis with support and confidence. From there, one second. Yeah. So we have a lot of other rules which are possible, a lot of other KPIs which are possible, which help in certain conditions. And they also, some of them exhibit a useful property called null invariant KPIs. So whereby you can reduce the data set under consideration to ignore the null KPIs. So essentially, if you're looking for a fraud pattern or some pattern in which some campaign-related promotion is running, you have, by using null invariant KPIs, you would be able to ignore all the rest of the fluff, rest of the transactional data set, which doesn't deal with the campaign under analysis, and only concentrate on that small subset which relates to data which have features or characteristics relating to your campaign. So that would help you go from a 1 million data set to maybe a 50,000 row record set, transactional data set, which you can do a deep dive analysis on. So that's where it helps. To showcase that, I have basically a screenshot just to show that quickly. What happens is, essentially, you Calc and IR are two of such null invariant KPIs. By in this visualization, we calculate it in three modes. First, the top half is these two KPIs as well as lift are calculated across the entire data set of 13, and you end up with their final values. And then on the bottom left, we calculate it using a partial match. So if any part of the rule is present in the transaction, then we include it. 8 such exist, and then the calculation is done over the data set, over the result set, for example, and then you end up with the same KPI. And finally, the most stringent criteria being that the rule is PQR implies A. So if either the antecedents or the consequent are part of the transaction, only then we consider it. We ignore all other rules, which are like, let's say, D and B. Transaction 11 has DB, but that's not related to the rule which is PQR implies A. So we would ignore 11 altogether. So essentially, this would be the mode of analysis for doing exploratory data analysis. But even across three transactions, the end result is the same. We end up with the same values for the KPIs, but we are dealing with a much shortened data set under question. So this kind of KPIs allow you to do self-service ad hoc analysis, and they would also be performant much more performant compared to the default calculation. So that's the main thing. There are many other benefits of SQL pattern matching that we are kind of discovering as we go on. So I hope this gives you a taste of what's in store in this session. Yeah, thanks.